Hello, everyone. Let me just check if everything's all right. That looks good. Hello, welcome. I'm Max. I'm an AR developer in Amsterdam. It's awesome that you could join here today. I'm really excited to show you this one project that I've been working on, and yeah, it's going to be a bit of a technical talk. I would like to first say that this talk was sponsored by Snap, and it will also be live streamed on YouTube, and it will be posted there, so you can watch it back later if you need to like rewatch certain parts of it. Yeah, just to introduce myself real quick, I'm Max. I'm in Amsterdam, and I've been working in AR for quite a while now, and I've been working with Lens Studio for almost since it came out. I'm a lens creator and ambassador, and yeah, I've really enjoyed working with Lens Studio. It's like always growing so much, and now this thing that I'm now going to talk about is also about a couple kind of one kind of new feature that I think has gone a bit overlooked. It's in the documentation, but it's something that nobody really knows about, I think. And one of the features is one that has been in there for a long time, which is MeshBuilder, but people don't really use it. And I'm just going to show how to, or I have not really seen a lot of people use it, at least. And I'm just going to show like how to do a basic MeshBuilder approach in Lens Studio. So that's quite exciting. So the lens I'll be making today, or the effect that I'll be showing, is how to create this body doubling effect. So it's using the body mesh, and it is on tap. It starts cloning the body mesh, but it pauses it. So on that frame, it creates like a paused copy of the body mesh, and it bakes the texture of the camera into it, so that you get these duplicates of the same body. You can actually scan the lens if you want to. And it's quite an interesting effect. Here I'm using it to trail, like to leave like a whole trail of a lot of them, which is a bit heavy on performance, but it works fine on a more modern phone. You can also just do it once every few frames. For example, if I show this, this video has a couple more versions. You can see like a trail of bodies being left behind, basically, when you just tap like once every few seconds, and they're really like tracked in world space in 3D. And the key feature to use here to make this copy of a body mesh is the MeshBuilder, and that is a tool. This is from the Snapchat documentation. It's a tool that allows to generate a mesh on the fly. So with JavaScript, you can create triangles or any other sort of like 3D model. And you can give it color, and you can give it like UVs. And yeah, that's really cool. You can just do that purely in code. You can create a new asset, basically. So you don't, it doesn't add to the lens size in that sense. It's a 3D model that's like free in terms of storage. And let me see. I think the first thing that I should show is, I'm just going to set up this a very simple project here. I've got an empty Lens Studio project, and I'm going to add a body mesh. And you can see if I set the preview to one of the dancing previews, this one, for example, you can see that it just adds a dancing body mesh there. And that's kind of that's what we want. We want it to like follow the body, but now we want it to pause at a certain time. So we want to create a copy of this body mesh that's paused. So I'm going to create a script for that. Let's just call that body double. And then I'm going to add that to an object in the scene. I'm going to call it body double. And let's open up that script. I'll be checking the chat in the meantime to see if there are questions, or if there's anyone who has like some comments on it. So I'm gonna Maybe if it's like a longer question, I'll do it at the end, but I can also do questions during the while I'm explaining something. So if you have any questions about something that I'm doing, just shoot them at me and I'll reply to them. So let's first make a function that starts when I tap on the screen, because I wanted to make one copy of the body as soon as I tap on the screen. So I'm just gonna create a function called onTap, and I'll just bind that to the tap event. So I'm going to create a tap event script.create event, and then between the brackets you just type tap event, and then you type tap event.bind. Tap event.bind on tap. So this is how you bind a function to some event that Lens Studio catches. So when the user taps on the screen, it's now calling this one specific function here. So I'm going to just print the number 1, for example, and then when I tap on the screen, it prints the number 1 to the logger here. So you can see that it works every time that I tap on the screen. It just creates a new print. So now inside of this function, we can start the cloning process, and we need to first get our the render mesh visual, which is the body mesh is inside of a render mesh visual component, and that determines every 3D model is always inside of a render mesh visual component, and that's the component that renders the mesh with the material. It's like it's allowing the mesh to be seen in the scene. So this render mesh visual also allows us to read out all the data of the mesh that's in it. And that's kind of a new feature. I always wanted that in the past, and now it's here, and I just figured it out by just reading the docs one day, and then suddenly I saw it. It was really cool. And it's like it's just a feature that allows you to read all the vertex positions of a mesh as positional data, or read out the UVs, or read out any attributes that's in the mesh. So that's super useful. And the process of how we're gonna copy this this dude into MeshBuilder is basically we're gonna copy all of that information that's inside of the mesh. We're gonna copy that into MeshBuilder and make it generate a new mesh based on that. So that's our whole that's the 2 steps that we basically have to do. So first, let's read that information of this mesh and just get all the data that's in it. So I'm gonna first create an input, and it's going to be component.render mesh visual, because that's that component that renders the mesh. So I'm going to call it RMV for render mesh visual. And then to get all the positions, we can create a new variable, script.rmv to get this one, and then we get the mesh inside of it, and we do extract vertices for attribute, and then between brackets we can put position. So this means that we we have to first give the variable a name. So for example, we call it positions equals script.rmv.mesh, and then extract vertices for attributes. So this means that now we have a list of all the positions inside of this mesh. I'm just going to print it, or first the length of it, so you can see the size of how much data is in this. So as soon as I tap, it should print the size of the data, but I first have to assign it in the inspector here. So I'm just going to drag this body mesh in there, and I tap, and it says 2,361. So that means that there is a list of 2,361 numbers in this positions list. And it's a bit weird because it's interleaved data. So that means that the positions, they are XYZ positions, but it's interleaved. So that means that it's one long list with following XYZ, XYZ, XYZ. So for example, if I just print the first item in the array, position 0, so that just prints the first thing that's in this whole list of positions. And then I tap again, then I get some number, 1.223, whatever. That's just a really long number. And it changes every time that I tap. And the reason that it changes is because the body mesh is moving. The guy is dancing. So his position is constantly changing. And this number is the first vertex on this mesh, and it's the x position of the first vertex. So if I do, instead of 0, I do 1, so that's the second one in the list, then you get the y position of the vertex. So that's 83 or 82. So that means it's a vertex somewhere over here, because that's the height, the 82. So that's like 82 centimeters up. So, or somewhere over here probably. So it's, yeah, almost a meter up from the ground. And that's basically what that means. But then if you go to 2 instead of 1, it will be the z position, so x, y, z. And then if you go to 3, then it's the x of the next vertex. So then it's again an x position, but it's because it's interleaved, you then go to the next position. So this list basically looks like this: x, y, z, x, y, z, x, y, z, x, y, z. And that's like the whole list, all the information in there. And I'm gonna, yeah, that's something that will come back later. So I'm explaining that now, but that's that will be there later. So that's good to know. And then we also need the indices. And indices, I can explain them using a quick illustration here. Imagine you have a mesh with some triangles. So I'm just gonna do some beautiful triangles real quick. Let's see, and this one. Maybe I'll connect these. So this is like a bunch of triangles in a 3D model. And then the positions, I'll make those red. So this is one position in the positions list. This is one position. This is one. So in total, there are 1, 2, 3, 4, 5, 6, 7 positions. And then the indices are the numbers, integer numbers that tell the mesh which positions together form one triangle. So these form one triangle, and these form one triangle, like these 3. So that means, so if blue would be the indices, then let's just give so for example, this position here, I'm just gonna put numbers next to the position so we can see them. So this will be position 0, this will be position 1, 2, and 3. Then to make a triangle of these positions, then the first indices would be 0, 1, 2. That would be this triangle, because it connects these three positions together. So you get 0, 1, 2. And then the second triangle would be 0, 2, 3. In fact, the 0 is connected to all the triangles here because it's in the middle, but that's just coincidence with this mesh. But it's the indices explain to the mesh which of the positions that we stored in this position list are actually connected together into a triangle. And that one is also interleaved. So you also, if we get the indices for this mesh, let's just do that by typing var indices script.rmv.mesh.extract indices. Let's see. That one doesn't need an attribute because that's just the same for all the points. If we print the length of this list, we also get a big number, 3,696. So that means that there's that many numbers in the list. And then if you divide that by 3, you actually get the amount of triangles there are. So if I tap now, it's 1,232 triangles. And that will always stay the same because the mesh always has 1,232 triangles. But so this list basically looks like, let's say, first position 0, 1, 2, then 0, 2, 3, then 0, 3, 4. All those positions together would be, they together make the indices list, but each 3 of them make one triangle. I hope this is not going a bit too fast. I'm just going to check the chat if there are questions. Increase the code font size. Oh, that's a good one. I'm not sure how to do that. Can I do that somewhere quick? Maybe this. Oh, that's very big. I'll make it a bit smaller. Maybe like 17. Is this better? Oh yeah, Control plus. Oh, well, but this is already a bit bigger. I hope this helps. So then we have the positions and we have the indices. And this is kind of the hard part in sense of like getting the information. So now we have everything that we need. We have all the positional data, we have the indices data, and we can now just start using MeshBuilder, giving MeshBuilder this information to create a mesh for us. So MeshBuilder has like a few things that it just needs in terms of information, and before it can actually create a mesh, and we're now just going to give it to him. We're just going to give MeshBuilder all the stuff that it needs, including these positions and indices. So I'm just going to go through this code, and then I'll explain it along the go. The MeshBuilder class is just a variable, so we're going to call it builder, and then equals new MeshBuilder, and then that's it. So now we have a MeshBuilder here, but it doesn't do anything at the moment. Then we can do builder. Actually, inside the MeshBuilder class, you can already give it the information that it needs. I'm just gonna take this from here. We're going to give it a list of this information that we have up here. You can already give that inside of these brackets, so that it already has all the right information. And then the information that it needs is just a attribute name. So this is going to be the attribute. Every line here is going to be one attribute on the vertices on the 3D mesh. So for example, positions is an attribute, color is one, the coordinates, the texture coordinates. So I'm just going to give it the name position, and then components 3. And that means that there's a position attribute which has X, Y, and Z information in it. And I'm just going to leave it at that for now. So we have the position in there, and then we're going to set the builder.topology, which is, yeah, a bit boring, but that's you just set the mesh topology. You have to always do this, and you set it to triangles. That just tells the MeshBuilder that it has to render triangles. So we're going to do the same for builder.index type, and that is mesh index type dot uint16. It's the only option there is, so you can't mess this up, but you do have to give it that information. This means basically half floats, if that makes any sense to the people. If you have a mesh asset in your project and you set the compression or the data type to half float, that's what this is. So but it's the only thing that MeshBuilder supports. So but you still have to like tell him that. So these two lines kind of always the same if you're doing this mesh copying thing. Then we can give it these indices. So we can do builder dot append indices, and then we give it the indices list. And then we do builder dot append vertices interleaved, and that will give it the whole array of all the vertices of positions right now that we have here. And I'm just going to put positions in there, because then it has this, it's going to put the positions into this list of positions that we gave it. So now it has all the information that it needs. What we can do is just say builder dot update mesh, and that's for the MeshBuilder. That's kind of it. The mesh is now generated inside of MeshBuilder. We can get it out of there by saying var mesh equals builder.getMesh. Then you just get whatever the latest mesh was that you built with it. And then we give that to, let's just create another render mesh visual, or just a scene object here. We'll call this body copy. And then I'll put a render mesh visual in there, which is empty. And I'll give that to this script. So I'm just going to copy this line. So we have two render mesh visual components. And I'm going to say new render mesh visual. So that's going to be the one that's going to render our duplicate. So then I say script.new render mesh visual let me check real quick. Mesh equals mesh. So now we're giving this new render mesh visual that we just made, we're giving it the mesh from MeshBuilder. Let's just save this and see what it does for now. So I'm just gonna, in the body double, I'm gonna drag in this body copy object. Now when I tap, it does create a mesh. There's something happening, but the position is off because I didn't parent it to this object. So this mesh is now at 0, 0, 0, somewhere different in world space. It doesn't always work very nicely to put, because this camera, eventually we're going to want to have a tracking component on it, which I'll just add for now. But yeah, for this demo, we won't really be using that. But usually when you make the copy of the body, you want it to stay in the position in the world where you made it, of course. So you want to be able to walk around it. But then device tracking and body tracking together, they create a sort of offset when they're in the same scene object. So you want to create this body copy outside of it. And then you can just copy the transform of this object over to this one. And that will create a sort of, yeah, then you will actually get the right position at that frame. And then it will look like it's tracked to the ground. So I'm just going to grab the body tracking object here, which is the one that we need to get the transforms. So I'm going to say input scene object, body tracking. And then I'm going to, right here, I'm going to say, let's set the new render mesh visual transform, script.new render mesh visual.get transform. Let's set its world position to the body tracking world position. So I'm going to saying script.body tracking.get transform.get world position. And then we do the same one for rotation. Set world rotation and get world rotation. So now it's just get world rotation. So now it's literally just copying the world rotation of body tracking and the world position of body tracking and placing it on the new render mesh visual. So when we give that to the body double, we just give this object here, and then we click, then you can see that there's actually a copy. Like this is a clone of the body mesh in the right position. So this is already working now. We could walk around this and it would stay in the position. Of course, it's looking a bit weird with the colors. And the reason that it's like so gray and it has these spots on it and everything is that we only gave it positional information and we didn't give it any normals or coordinates or anything. I think that's going to be next step. I'll just check the chat for now and see if there's anything that we need to. If anyone has a question so far, like do ask me, or like maybe if you want me to go slower or go over something else real quick, then just let me know. But yeah, so the next step would be, let me see. Cool, thanks. So the next step would be to give it normals and also give it UVs so that we can actually bake a texture into it. That's actually like attribute information that it needs. So that would be, this is where the interleave data becomes important, because usually if you want to bake a texture, you would use, well, let's just do it right now. Let's just try the baking a texture into it. I'm going to say script.new RMV and then .snap. The snap function is a function that actually overrides the UVs on the mesh with just the screen space coordinates and that current frame. So then if you give it the screen texture, it will look like it's projected, like beamed onto the mesh because it's screen space. And then when you walk around it, it actually sticks to that mesh that way. So that's the perfect way to bake textures into a mesh. But I can't show that right now because it doesn't have any UV information on it. So this snap function won't even work because it doesn't know which attribute to overwrite with this information. So we're going to need to give it the UV information here. In the attributes, we need to add a second line. And this one we can call texture 0. And Lens Studio recognizes that, or any 3D software will recognize that as the attribute that controls the UVs. That only has two numbers, X and Y. So where position is X, Y, and Z, a UV map is only X and Y. And that means that now that it does have a texture 0 with 2 components to it, but then it has a problem, and that's that the append vertices interleaved is not matching anymore. So let me just show what I mean. If I remove this snap function and I just save this, and then I tap, it gives me an error, wrong number of vertices. And that's because it's expecting there to be, for every vertex, it's expecting there to be 5 numbers, 3 for position, 2 for UVs. But instead it's only getting 3 numbers because we give it only the positions array, which only has 3 numbers in it per vertex. So that's a problem. We now need to kind of give it 5 numbers, and it doesn't even matter what the numbers are because we're going to overwrite the UVs with the snap function anyways. So what we're going to do is just loop over this positions array. So I'm going to create a for loop. Let's just do that right here. I'm going to loop over this positions array and create a new array that has the positions in it, but it also adds 2 more numbers at the end of every 3 numbers. So we're going to loop through positions dot length divided by 3 because it's X, Y, and Z, X, Y, Z, X, Y, Z. And then let's see if there's any questions so far. Doesn't seem like it. And then we can just create a new array here, and I'm going to call that vertices, just the empty array. And in vertices, I'm going to add, well, first the positions at this frame. So that would be positions, let's see, I times 3 plus 0. I have to peek a little bit at the code I wrote earlier, but this is, yeah, this is right, because then you get the positions of the current vertex that we're at, and then plus 0 is because we are first at the first vertex, then plus 1 is the second vertex, plus 2 is the third vertex. Of course, the 0 doesn't matter, you can leave it out, but I like it for readability to put it there, because then you know what you're doing with these 3 numbers. So then you have the, now you have X, Y, and Z already. So this is the vertices list is now exactly the same as the positions list, basically, because we're going over the first one of the 3, and then we're adding all 3 neighbors next to it. So that's, now it's just cloning the positions list into a vertices list, except now we go over each of the vertices, so we can add 2 more. So I'm now going to do vertices.push, and we can just do 0, because it doesn't matter what you add here, because we're going to use, we're going to bake the texture in anyway, so we're going to overwrite the UVs. So I'm just going to push 0 twice. And that's these 2 components, X and Y. So I'm making interleaved data here, where it's just one long array of 5 numbers per vertex. And then if you just do this, it will work again. Now it doesn't say wrong number of vertices. It does have to load a while. Let's see what's going on. Maybe I made a mistake here. That seemed like it was very heavy. Positions. Let me check. Oh, I'm not exactly sure what that was. I'm gonna just right now, there's one thing that I forgot. We have to use the vertices array now instead of the positions array, because the positions array, we're using that here in the append vertices interleaved, but I have to now add vertices because, yeah, we just changed the positions array to have, we just made a copy which has the X, Y, and Z information plus the texture 0 information in it. And then, yeah, I mean, this should be working. This should be all, because now it does the plus 0, plus 1, plus 2. So I'm just going to save this. Now we click. It is having some It's loading for quite a while. Like it's free. My screen is freezing when I tap. I equals 0. Sorry about that. I just have to check real quick if there's something that I'm not taking into account here. I'll just, if anyone have a question in the meantime, check the for loop. Yeah, if anyone can see what's going on. I am kind of sure that this should be it. Positions. Yeah, it seems like the for loop is like infinitely going on, but I'm not sure why. 1 + 2. Is there any other smart people out there who are like, oh, you gotta fix this and this way? Let me know. I'm not 100% sure how this is happening. May have to do, the condition of the for loop is not correct. Oh shit, you're totally right. I forgot to put, that's it. Of course, the for loop has to have a limit. I forgot to put the I equals smaller than. So thank you so much. That was a very stupid mistake. So now when I tap, there we go. We have our body mesh copy. Thanks. Who was that? I gotta give credit to that. Ibrahim Bona, if I pronounced that correctly. Thank you so much. So we now have a body mesh that's cloned, and it's now got UV coordinates in it. I made it 0 everywhere, so it looks really weird. And this lighting is also weird because it doesn't have normals on it. So everything looks a bit weird, but the information is there. So that means that if we just give it a material, I'm just going to create a graph empty, call it test, and then put that on the body copy. And then I'll open that. If I just visualize the coordinates like that, this is the UVs. Oh yeah, right now it will still show 0, like it's black now because we made it 0 in the code. But then in the end of the code, if we just snap the render mesh visual and we do, so we say snap, and then we need the camera. So we're going to do script.cam because it needs to snap from a camera perspective. So I'm going to add the camera as a component here, component.camera. And then it has the camera and it's just going to snap this mesh. Let's just give it the camera there in the inspector. So now when I tap, you can see that it has this nice green and red gradient. And it's exactly as screen space is, but it's a 3D model. So that means that it's now overwritten the UVs on the mesh to be screen space. So if we then give it a texture, and we can remove the surface coordinates, and we just give it a texture, we just call it like base text or something. And we plug that into the color of the shader. Really as simple as that, just one texture node and a shader node. And then you tap, then this texture will, as you can see, it will be screen space, the purple black cube, because we didn't give it any texture. It will be like matched to screen space. It will look very flat, 2D, which is what we want, because then we can put the screen texture on this. So I'm gonna, in the code, I'm also gonna give it the material, which we're gonna bake the texture into. So this is gonna be called the body material. And we're gonna give it the screen texture. Screen text. And then over here, after the snapping, we can just do body material.mainPass.base text equals. So we're gonna give it the base text. And then what we're going to give it is screen text. So we're going to do script.screen text, but we don't want a live version of it. We want only this frame. So we're going to do copy frame because we want to bake this frame. So this copy frame function gives you a new texture, which is just a paused version of at this frame. So then when we save that and we give it the right stuff, so body material, which would be this one, and the screen text, which would be the device camera texture. And then when you tap, you can see that it's leaving behind this clone. And it's actually intersecting with the one. So we can even disable the body mesh for reference. We don't need that. So every time you tap now, you can see that it's actually creating a body mesh there in 3D, which is, yeah, it's like a really cool effect. It's of course, it's way more fun to try on a phone because then you can actually walk around something and you can see it. We can, on this body mesh, we can give it an occlude material. So let's just add an occluder and throw that into the material here. And then when you tap, you can see that it's the body materials occluding with the 3D material. So you can see that it's an actual 3D effect. Like his face is intersecting with his old face. And every time you tap, it's just updating the mesh. But of course, you can also make the mesh stay and create a new one or something like that. So this is a really cool effect. And it's not just with the body mesh. You can do this with any mesh that you want. You can do this with your own mesh assets if you have them, if you need, for example, a copy that you want to snap the UV coordinates off, but you don't want to import it twice into your project because that costs a lot of lens storage space. Then you just do it using MeshBuilder once, and then you have a duplicate of your asset, which you can change without changing the original one. And that saves you a lot of like lens space. I also use MeshBuilder for just generating high-res planes. If you want like a plane that has a super high resolution for shaders, then you don't want to import an OBJ file with a lot of vertices in it because it's just a plane. So you can just use MeshBuilder to generate it on the fly, and it will be like one frame. It will be a bit heavy, but then it just has the asset, which is super useful. So let me just check real quick if there are any questions. Doesn't seem like it. If there are any questions about any step that I took here, because it's not a lot of code, but it is quite dense, and I went over it quite fast to stay within the time. So I hope that it all makes sense. One thing that I also want to show is that these attributes, like position and texture 0, you can add more of them, and they are not all of them have a real meaning. Like position is linked to the actual position of the vertex, but you can also just add your own with a random name, like 3 A's. And then in the material, you can actually do a custom vertex attribute, and you can read it here by typing the name, AAA. And then you get the attribute that's on the mesh. So this works the same as, for example, in an FBX model, where you would have custom attributes, which is sometimes super useful for shaders. And so you don't need a texture with a certain type of information on it to, drive the shader in some sort of animation, for example. But you can also just do that through this, or this node in general is really cool because it allows you to read out any custom vertex information from any 3D software. So yeah, that's a fun link between MeshBuilder and this one that I found that can be really useful. And I think that's it. I'm just going to check my notes if there was anything else. But I feel like I've gone through everything here. Yeah, so I went through it really fast. So if there's anything at all, are you aware of performance limits to using MeshBuilder, like a certain low poly count where you see lenses start to slow down? Yeah, that's a good question. MeshBuilder is a bit heavy, as in if you would do it on every frame, for example. But my body copying lens actually holds up really well on like the bit more modern phone, but on an iPhone, for example, on a modern iPhone, it works just like 30 FPS, and it's fine with this body mesh. I wouldn't generate like 10,000 polygons every frame. That would be too much, but you can do like more on the low poly end of meshes, which the body mesh also is. You can easily just generate them like once every few frames or something, and it won't drop the performance too much. I think the heaviest part actually of this whole code is going through the positions, like this for loop. I think the MeshBuilder is actually really optimized, but then this for loop is probably the bottleneck. So it could be even faster if you don't need the extra attributes for the UV coordinates. If you don't need these UV coordinates because you're not gonna use the snap function, for example, then it would probably allow a lot more. But yeah, it's kind of just checking how you're gonna have to test. I also, for example, don't know if this function, the extract vertices for attributes, I don't know how heavy that one is if the mesh has more attributes. I'm not sure how that works internally, performance wise, because this mesh builder, of course, doesn't have a lot of attributes. It only has normals and position and UV coordinates, I assume. Maybe also like weight painting stuff now, actually, now that I think of it, but it's not a super heavy mesh in that sense. So then it works quite fast. Yeah. Let me see. So I think that's it then. I'm really curious. I'll clean up this project and post it so you guys can like use it yourself and kind of learn from it, or use it for your own lenses. I think it's a fun little technique. You're welcome. Let's see. Yeah, I think we can end the call a bit early if there's no more questions or anything. All right. Yeah, thanks all for coming and watching this live, or if you're not live, then thanks for watching it later. I think it was really fun. And thanks, Ibrahim, for fixing the for loop thing.